section of material, basically, from here to the end. We've got chemistry to do from here to the end, and that's what we've got. So we've got this stuff, which is atoms in the periodic table, which I think you guys already had a dose of in like 6th, 7th, or 8th grade, depending on maybe which school you were at or how they did it. So we've got that to do. We've got chemical bonds, which will come after that, and then we've got balancing chemical equations will be our last bit. So that's what we've got left to finish off the year, like 3 tests to go plus a final, and that's that. That's all we've got left to go. So this one is on atoms in the periodic table, is what we'll start with. And the question was, on page 36 in your interactive notebook, give me 3 things you know, 3 things like maybe you used to know that you don't know, so things you would like to know, and then 1 question that you still got left about atoms based on what you know already. So what I'd like to do is get a list up here on the board of the things we know. And this will help me figure out where I need to pick up with you guys, because I know that you've done this before, and some of you guys are probably fairly advanced, like in terms of what you know about atoms. So I need to know where I've got to start teaching with this stuff. So if you wouldn't mind, let's get a list. Lindsay?
Everything has atoms.
Okay, yeah, that's a good one. Is that true? Does air have atoms?
Yes.
I'll think, yeah, air's got atoms. Yeah, Lindsay, I was trying to see if you understood what she said. Everything that is matter is made up of atoms. So what's bigger, a cell or an atom? Cell is bigger, yeah. So number 1, if you didn't know this, atom, how did you say it, Lindsay? Everything is atoms. So I'll shorten it like that. So that's true. Everything that's out there is made up of atoms. Do you know where there's a whole list of atoms? Yeah, right there. Everything you see on Earth, everything you see in space, everything you touch or feel, even things you can't see like air, are only made of that stuff. That's the only stuff that's out there. It's kind of like a cookbook, you know, when you want to make chocolate chip cookies or something like that. There's ingredients you need to mix together to make them. Those are the ingredients that make everything that exists that we know of. Nathan?
Okay, so if everything is made of atoms, and so the air is made of atoms, why isn't it like a wall? Why aren't we just trapped?
Because it's a gas. You're thinking of solids, right?
I guess so. But
Yeah, solids, liquids, and gases.
But if the actual atoms themselves are technically solid, then...
Gotcha. All right, go ahead.
Atoms are or are one of the smallest things in existence.
All right, so I'll just write that they're small. Which is true. They're super small. Can you see them with a microscope? Nope, can't even see them with a microscope. You need something even smaller than a microscope. I don't even know, and I should know this, I don't know if we've ever seen an atom. I know that we can break them apart. We've got this... Yeah, we've got this, it's called CERN, I forget what it stands for, but in Europe they've got like I think it's a 12-mile loop that they use to speed up atoms, and then they crash them together and kind of take a picture of what was there. Which, the first time they did it, some of the world's leading scientists were concerned, like, hey, please don't do that, it's going to cause a black hole, it's going to suck the world in, and the people that did it were like, we think we'll be alright, so they just did it anyway. It turns out didn't make a black hole, and we're all still here, but could have, and that would have been the end of us. So anyway, everything's made up of atoms. Atoms are super small. What else, Skylar?
They're like protons, neutrons, and electrons.
So they're made of protons, neutrons, and electrons? Very good. So I'm going to write pro, nu, and electrons. So they're made up of protons, neutrons, and electrons. That's a good one to have. What else about atoms? Remember, perhaps, for Madison, what the center of an atom is called? Yeah, very good. So, it's true for both. Middle. Nucleus. Nucleus. And there's two of these 3 things hang out in the nucleus. Do you know the names of the things, Aubrey, that hang out in the nucleus? Very good. So I'm going to write P and N are in. And do you remember what the places that the electrons spend their time in is called? There's two different words for it. One word is called the electron cloud, or energy level are the two words for it. So protons and neutrons are in the center, and then electrons are in the outside. They're in the energy level, or in the cloud, or the energy level that's out there. What else for stuff that you know about electrons or atoms? Randall?
There's a lot of empty space between where the electrons are and the nucleus.
Yeah, that's good. So I'm going to stop numbering them here, but lots of empty. Do you know about atoms and movement? You know anything about that? Like atoms moving around? Skylar?
But when they get hotter, okay. When they're colder, they're more closer together. They don't move as much.
True.
When they're hotter, they like move around more and they like vibrate kind of.
Yeah, very good. Yeah, think of yourself at like a 1 Degree concert or something like that, where before the band starts playing, everyone's kind of huddled around. You know, everybody's squished in to get a look at Harry Potter or whatever up in the front. And then once they start playing their quote-unquote music, the people in the audience start to move around. So consider that like atoms and heat being applied to it. As the heat's applied to it, they start to move around, and there gets more space in between them. They move around further and further. So it's true, yeah. As stuff cools down, atoms move less and less and get closer together, and that's what creates a solid. And as they get hotter and hotter, they spread out, and that's what turns it from a solid to a liquid, and then a liquid to a gas, and so on. Did I have that right, Des? Is it Harry Potter and 1 Degree? No. I'll get it one of these days. Anything else about atoms and stuff like that? All right. What about this? Weird to think that the atoms in you have been in other things. For instance, where do you get the atoms to make yourself bigger as you grow? Where does it come from? It's got to come from somewhere. How do you? Yeah, the food you eat. The food you eat stacks on and makes you grow taller or bigger. The water you drink helps you do the same thing. So let's think back. Those atoms that you take in through food, they come from like lettuce or a cow or whatever, right? And those things, what was the lettuce before it was lettuce? Close. Parts of it were dirt, right? It took up vitamins and nutrients from the soil. What else was part of it? Water, carbon dioxide from the air. And then what do they spread again on crops to help them grow? Yeah, and what is fertilizer?
Dung.
What's dung?
Animal excrement.
Yes. So the atoms that, when you're eating your nice lettuce sandwich, those atoms that are in the lettuce are only one step removed from being dung, to put it in Nathan's terms. So you're eating like poop, but you're one step away from poop. Okay, so that only means you're 2 steps away. Cows eat vegetables, right? Grasses, things like that, which use poop to grow, so the cow eats things, so you still get the turd. You're just getting it one step further away from where it started, which is kind of gross. And you're thinking, oh, or maybe you're thinking like, oh, that's so disgusting. Well, you can look at some cool stuff about it, because those atoms that are in the poo now or in the lettuce now or whatever have been around for billions of years. They could have been once dinosaurs, the atoms that are inside of you. They could have been somebody else, like previous, way back when. You could have atoms inside of you that were part of Julius Caesar, or atoms inside of you that were part of Cleopatra or something like that. Those things are around. The other thing to think about is that nice bottle of water that you have. Since all matter here on Earth gets recycled. When you drink your nice, cold, fresh water out of the bottle, like Evian or whatever it's called, Levian, I don't know. What is it? Faucet water for me, Fiji, whatever. You drink your nice water and you're like, oh, this is such fresh, clean water. I'm glad I'm drinking such fresh, clean water. That's great, right? But when you do a number one and you flush it, where does it go? It goes to the sewage plant, right? Does its thing. And then from the sewage plant, where does it go? Into the rivers, down into the ocean, where it evaporates and then rains back down upon you where you drink it. So, the pee that you got rid of, or that some other person you've never met got rid of last year or last week or 50 years ago, that has been like processed and in a river and then it rains back and you're just drinking it again. So the water you're drinking has already been drank before, and probably multiple times before. So remember that as you're paying $2 or $3 for your bottle of recycled and processed urine, that looks nice and clean now. Because it is nice and clean. There's no way around it. You need it. But it's already been used. Hate to tell you. So, on that note, I'm thirsty. Yeah, Nathan?
So what you're saying is that everything...
Those atoms that are on the periodic table right there, and they've all been recycled. They've all been used, and they will all be used again. When you're used up and gone, somebody will use up your atoms, the stuff that you're using right now. Even in terms of like how you breathe. The stuff you breathe out, other people will breathe in. Somebody famous, when you went to a concert for like your One Direction or your One Degree concert or your Justin Bieber concert or whatever, you go there and he's breathing out, you're breathing in the same air that he is. Oh my gosh. It's like...
Is that bunch of blank ones, like 110, 111, 112? There's 130, 114, but those ones even have that.
We'll save that for the question time. It's one of my favorite ones to do, believe it or not. All these ones are. It's all like fun and like logical to me. So hopefully you guys find it the same way. One of the things you're going to be asked to do, and that's why I gave you the periodic table now, is to memorize atoms from 1 to 18. So that's going to be name, number, and symbol, from hydrogen all the way to argon. And there's a couple ways to do it. The one way is, just do one a day with a flashcard or something like that until you get there. And the test for these will be when we take our test on the unit. The other way, and the way that'll stick with you probably most easily, is if you go to your YouTube machine and type in periodic table elements in order song. The song just sticks in your head. It's childish. It's going to annoy you because you won't be able to get it out of your head, but you're guaranteed to remember the elements. 2 to 3 weeks out. So, and if you're thinking like, oh, that's so not cool to have the element song, that's like lame. But the dude from Harry Potter, the Harry Potter actor, Harry Styles or whatever it was, he was on one of the late night shows and he recited all the periodic table of the elements things. So just in case you don't think it's cool, Harry Styles knows them all in order. That's the host. It was either him or Jimmy Fallon, one of the two. Probably Jimmy Kimmel. But yeah, Harry Styles, he knows them all. And Harry Styles can rap. Who would have thought Harry Potter can rap? It's true. You can look it up. So, what we are going to do today, we've got 2 things basically to do today. Number 1, you guys grabbed this when you came in. This reading, it says on the front, atomic structure right here. So what I'm going to have you do in your table group today is you guys are going to go through, and this is on page 36 as well. So on that page 36, and if you need room, you're going to tape a piece of paper in there. You guys will read through this short article on atomic structure, and you and your group are going to highlight and write down on that Cornell Notes paper the things that you find to be most important. So we're going to go through, and we want all the information that's important out of there. When you're done with that, I'm going to go over with you how to incorporate that information into what we're going to do today, which is called a Bohr diagram. So those are the 2 pieces today. And as you get your Cornell Notes set up for this, your essential questions right here. And it says, how do atomic components influence the atom? So how do the parts of the atom influence the atom? So again, in your table group, you want to be on page 36. You can highlight, you can write, you can do whatever on that piece of paper. But the information from there needs to go into your notes on the Cornell notes. 36.